for joining us this month. Okay, but before we continue our presentation, I would like to give an safety announcement that we do not have any emergency drill planned for tonight. So in case of the alarm goes off, please remain calm and and look for the nearest exit, which are all clearly marked. The hotel staff will guide you down to the assembly point outside. And it's important that everyone do not rush. Also, if you observe any suspicious activity, please inform our staff immediately and do not hesitate to do so. So here is our agenda. I will highlight some of our activities. So we will have presentation followed by Q&A, closing remark, and lucky draw at the end. Section announcement. The industry here in Thailand is very unique and perfectly fit with our mission and visions. So we here to network and we share. In 2025, we continue with our mission to keep you informed with what's going on in our industry and make new knowledge available to you. This company has sponsored for us in this year to support our Thailand technical meeting. And for anyone who want your company name to be here, please reach out our staff to register. Our SPE member, there are more than 680 total members. And there are about 280 people who lost the membership last year and haven't continued their membership yet. So if you check your membership status, please continue your and renew your membership status. We have 295 professional and 387 students from Chulalongkorn University, Suranari, Prince of Songkla, Chiang Mai University. These are our student chapters. On the topic of SPE membership, there are several benefits that you can gain from being the membership. I will not go through all of it, but I will highlight some. You will belong to the one of the most active SPE in the Southeast Asia, and you have an opportunity to networking and sharing the valuable insight together. So you can socialize with our peers of the same interest in our industry. But before we go to the main presentation, so we have this time we have the special announcement from Dr. Trin for the Thailand 25th bidding round. So welcome Dr. Trin on stage for giving you information.
Okay, thank you. So I'm Trin. I'm a geologist and head of petroleum economic group from DMF. So it's been 15 years, right, since last bidding round in this area. 15 years is a long time. So 15 years ago, I just joined DMF not too long. And I must sincerely thank Ministry of Energy for signing the bidding round and DMF staff management to convince him. Yeah, that's great. So we will have 9 blocks in the northeast, 7 in the northeast, and 2 in the central. Right. So 7 in the northeast, you're probably familiar with the play, like carbonate play, right? But I want to remind you that the USGS did the shale gas, high gas study a while ago, and they said there's two TCF of gas in the northeast in shale gas and Thai gas. So you can go and check that out as well, right? For the 2 onshore blocks are oil, right? And contract term is basically Thai tree, which is 3 years plus 3 years plus 3 years of expiration, and 20 plus 10 for production, right? And fiscal regime is step royalties 5% to 15%, depend on production rate, 50% tax, and windfall SRB as a windfall tax, right? So basically, same system, not much change, right? And I want to remind you that L L6, which is this block, right, is in the uh, World Heritage area. So we announced this block a few years ago, and then later on the World Heritage announcement. So this area become World Heritage around the producing oil field here. Just south of it is a World Heritage. So it is unlikely that no development can go further because the fine art department will further announce the buffer zone of the World Heritage. So probably the whole Phetchabun province will not be available for future oil and gas. But Suphanburi still okay. About minimum coverage, minimum works. Basically, for L1 and L3, there will be well requirement to drill a well on the first exploration period because these two block basically this one surrounded by existing Nampong and Puhom field, and this one surrounding discover production area Dong Moon, right? So it's basically these two blocks are surrounding exploration with discover gas, right? And also a lot of available seismic, right? And the rest of the block required to drill one well on the second period of the exploration, and the seismic requirements here, right? Minimum signature bonus is 100,000 USD, right? Bidding schedule basically is a bid round already announced last year, and data room is already open since 3rd of February, right? And there will be a bid conference on March 6th March, right? DMF already sent this is invitation only. So DMF sent invitation to existing concessionaire and contractor and service companies. So if you did not get invitation and would like to attend, email petroleumbidding@dmf.go.th to request for attendance. Basically, there's I don't know if you remember, but we have NGO breakthrough a bit one of the bid conference and lots of mess. So we want to make sure that you not cause trouble. That's all. Right. The bid conference will be at the same place as uh, the Shinawat Tower 3, same place as bidding 20 if you attend. I don't know. Some of you probably attend the 20 bidding round. And data room already open. And to get the access, you can email dataroom@dmf.go.th to make reservation. It will be free of charge, and they will have access for 2 days. The room is small, so it's only fit 2 or 3 people. Basically, the goal is to preview data sets. So not all the data set will be available in the data room. Only some are selected. So, but the data set is here to see a lot more data is available, right? To get to a data set, you go to DMF website and go to 25th bidding round website and data access and click on the tab of data set. Right. So data sets can be purchased. You can select seismic line that you want. You can select well that you want. All the price will be available and you, in the Excel sheet, you can check out the detail later. Okay, that's it. Thank you for your attention. If you have more questions, go to the website, right? And you have questions, in general questions, go to email Petroleum Bidding. If you have a question about data room, email data room. If you have question about data set, email DMF e-commerce, right? Thank you.
Thank you, Dr. Tin, for the useful information about 25th bidding round. Next, we will move into our main presentation. So, ladies and gentlemen, we will continue our main presentation. And can we please to have Kun Kasian to introduce our keynote speaker?
Hi, good evening. Doesn't seem to. Hi. Okay. Uh, First of all, I'm sure most of you know me. My name is Kasian. I'm the SPE program chair. I come here almost every meeting to introduce a speaker, but today, the same day, 20 of February 1980, was the first day that SPE Thailand was incepted. So this year, 2025, this is 45 years of SPE Thailand. Can you imagine? We've been so long. And so on September, where we usually have our season opening, we will also combine with the 45-year anniversaries. We don't know what's going to come up, but please mark your calendar and join with us to celebrate the 45 years. Okay. So without further ado, let me start introducing our speaker for this evening. Okay, our speaker is the distinguished advisor. Actually, his bio is extremely long, right? It's going to take me an hour to read, so I just capture just short parts of it. Okay, he's a distinguished advisor for completions and well enhancement at MEDCO Energi. Previously worked in BP, their JVs and partners company for more than 39 years. Having lived in 12 countries and worked in over 55, he has truly international footprints in well enhancement, fracturing, and stimulation services, as well as well control and multilateral drillings. He is both a co-author and a principal author of more than 200 industry technical papers, articles, and patents. Speaker has been the SPE Distinguished Lecturers in 2007, 13, 18, and once again in 2024. He has received the SPE Completion Optimization and Technology Awards for the SPE Gulf Coast sections in 2015, and then SPE International in 2021. He is a contributing editor of the JPT, a reviewer, the current and past chair of the SPE Hydraulic Fracturing Technical Sections, directors of SPE Management Technical Sections, and continue to serve on a number of diverse SPE committees. He holds first-class honor with degrees in mathematics from Salford University. He is a chartered mathematician and a fellow of the Institutes of Mathematics. Ladies and gentlemen, please join me on a warm welcome. Our speaker this evening, Martin Rylance, Distinguished Advisor from MEDCO Energi. We need to speak a little bit closer.
Yeah.
To fire. Right.
Okay. Okay. Well, thank you very much for that introduction, and we'll get underway. Thank you for the invitation and the opportunity to speak to you this evening. Hopefully, this will be an interesting story. So I'll run through the rough outline of the talk tonight. The slides will be made available to everybody in the section, so no need to scribble away. But I'm going to talk about a development in eastern Siberia, and for those of you who don't speak Russian, nie говорит по-русски, it's the Tash Yurak Neftegastobiche Shredno-Botyubinskoy oil field, or as we affectionately knew it, TYNGD, just a lot easier to roll off the tongue. So I'll talk about the overview and characteristics of that, and what was the opportunity that we stepped into. Post formation of the non-operated JV that was put together to manage it, the ramp up and the development changes that had to take place, including the appraisal results. And this is a multilateral development, but that came after we started, if you like. And then during the development drilling, what the problem statement, what occurred, and how it was managed, the considerations were reviewed and how it was managed, and were at least as up to date as I can be, given current restrictions on talking with and obtaining information from eastern Siberia. So heading into the first part, it's a high permeability formation, a thin layer, about 150 millidarcy, a clastic reservoir remotely located in eastern Siberia. And when you think about remote locations, this field is about 1,000 kilometers north of Lake Baikal, where Irkutsk, the city of Irkutsk, lies. And Irkutsk is a city in Russia that is about 1,000 kilometers from anywhere, and so 2,000 or 3,000 from Moscow. It's in the middle of nowhere. Getting the logistics are very, very difficult to get to this area, and that forms part of the problem, if you like. There was a very aggressive development plan. There'd been an original operator, an incumbent, who were drilling 350, 400 meter horizontals, but gassing the wells out very quickly. And BP stepped in with their partners Rosneft to pick up the development. But again, the logistics mean that if you move 10 or 15 rigs into eastern Siberia, you go in, you drill for 3-4 years, and they come out and go where they're going to drill again. There is no market. Everything has to be hauled in. On winter roads, there's some limited river access in the summer. But as you're probably aware, a lot of western and eastern Siberia are very swampy. Or in the case of this, it's just tough access. And the original development plan, as I say, by the incumbent, were these about 400 horizontal wells of 350, 400 meter lateral length, but not being successful with their early appraisals and effectively ran out of money. This is what the field looks like, a cross section. Ideally, it had been thought that most of it was above water and a little bit below gas. That changed as the development progressed. Looks like this. It's about 15 kilometers wide and about 80 kilometers long. Multiple layers, but the principal reservoir, the SPE, at about 1,600 meters, with a gas oil contact that had been drilled. Variable oil column thickness, 10 to 15 meters, and an original oil in place stock tank, about 2.7 billion barrels of oil and 4 TCF of gas above it. Slightly 8 centipoise viscosity oil and slightly under pressured, nothing really unusual. Originally discovered in 1970 and was under development. A lot of these fields, a lot of these discoveries under Soviet times were effectively, there's just sewing machine drilling going on in a number of these places down to certain depths. And so lots just to determine, it's almost like an assaying project across Russia. So yeah, the discovery was made in the 1970s, but no plans to develop it anything like close to that many, many decades later. So the incumbent operator was drilling wells about 5 meters from the gas oil contact, drawing down about 300 psi, and not surprisingly, the wells gassing out. Placement a further 10 meters from the GOC, an extension to 750 meter horizontals, and then 1250 with a more limited drawdown allowed some more longevity to be put into the wells, if you like. But a plant was being built well underway that could produce 100,000 barrels a day. This approach, because more of the field was turning up below gas than originally perceived, was not going to deliver the PI on a well basis to fill that plant. The obvious answer would have been to produce at 50,000 barrels a day. And pace the development appropriately. The management don't like that when they've invested in a plant that's twice that capacity. And the rigs are arriving. You know, the logistics are in place. You've got the winter arrivals coming. We're up to 15 rigs now, constantly increasing. So real problematic. And this is just a plot of what this looks like. Here we can see a GOR increasing on the original well styles, and when we were able to drill some of these wells, we could keep the GOR in a more reasonable position, but there was a limited amount of thickness that allowed this to be done, and a limited amount of locations that we could pick to progress that. So had to think of other solutions, and the next solution was to start determining what a more appropriate drilling approach might be. Appraisal information started to come in from the southern wells, indicating that it was mostly below gas and not above water. The STOIIP reduced conveniently from 2.7 to 1.8, which put more pressure on the team to make this an economic outcome. And as I say, northern bias with the formation shallowing to the north, so getting closer to the gas. And the field geometry moved from this 25% above the gas and 75% above water to much more the other way around. So a real problem. Plant commissioned, expectation of 100,000 barrels a day, smaller field, reduced drawdown. How are we going to manage to deliver that? This is what the core of the field looked like after the appraisal well, further appraisal had taken place. And there was a solution. It was a very relatively straightforward one. It was Canadian style, TAML 1 level multilateral drilling. Very, very successful. Started in 2016 and passed through 3 phases of experimentation in what could be done. This is what a standard multilat started to look like, with, in this case, 7 laterals and the mother bore just tailing off there. So, and these were delivering about 6,000 meters in the reservoir versus the original 350, 400, 750, 1250. So basically a lot less drawdown, but a lot more exposure within the reservoir. And now you're able to deliver the PI on a well by well basis that will give you a solution for the same wellhead count or less. So this simple TAML 1, originally all open hole, drilled out from the heel, as I say, Canadian style. If you go to the Shaunavon, which is kind of the tight sands north of North Dakota, getting into Canada, you'll see wells with 25 and 30 and 40,000 meters drilled in the reservoir. As long as the drilling's fast in the reservoir, it's a really great way of creating PI. Simple junctions, though, is the solution. And in this case, we did start to add a mother bore. So we would run a liner in with swell elements and a sliding sleeve opposite each lateral window, so that if GOR showed up when you're changing ESPs out, you have the opportunity to experiment with closing a sliding sleeve or two very easily, very straightforward. You're going to change the ESP. It's just a little bit more jointed pipe to go on a pulling unit to go and close one of those sleeves. So able to deliver 6,000 meters in the reservoir in a single well. 12,000 meters was the record, something we called a birch leaf, and assisted with the productivity at this reduced drawdown, and scaled up post phase 3. And now about 10 of the 12 rigs that we had were capable of drilling these. The standard multilateral with 9 laterals and 6,000 in the reservoir. So quite a nice, a huge learning curve that's in the papers. This talk isn't really about the multilaterals, but the window cutting in open hole within the reservoir was originally taking about 12 hours to do, and I think they got it down to an hour and a half. So it just gets faster and faster and faster, as drillers tend to, and relatively straightforward. Usual pad completed with 15 horizontals by the incumbent on the original design, 400-meter horizontals, but a multilateral pad only requires 7 wells. Average drilling time was about 40 days for one of these 1250-meter horizontals. Started with about 60 days, down to 50 when I left in 21, and I believe down to about 35 now on providing these. The PI increasing 4 to 5 times on a conventional horizontal, and the cost just fractionally more. In terms of you're in the reservoir, you've done the overburden piece, and now you're just adding adding reservoir coverage, and the numbers work out here. So an 8-well multilateral pad can deliver about 8,500 barrels a day for about $28.5 million, where standard 15-well horizontal delivers just over half that for considerably more cost. But that's not what this presentation's about. We've been presented with one problem. The reservoir's totally changed. It's halved in size. It's mostly below gas. What are you going to do? And the reaction time was quick, and everybody came up, pitched in, multilaterals, straightforward. Now we're great. Now we're hauling oil off, and now we're getting major losses in the reservoir. There'd always been losses in the reservoir, but now there's no gas injection taking place because that bit of the plant they haven't built yet. But they want the 100,000 barrels a day. We're drilling the wells fast. We're hauling the oil off, and things are going to hell in a handbasket in terms of losses. So, quick overview of the casing design. There's an upper cemented piece just out of the casing above the reservoir that requires this, but it's open hole with this liner in. Pore pressure just subnormal. There'd been no LOTs measured, or FITs, I should say, at all during the original work. So some leak-off tests were taken, and the fracture gradient appeared to be well above what we thought was the fluid, the fluid density, the ECD in the reservoir. However, there were features. We'd had losses in the reservoir. So just think of it on a probabilistic standpoint. You're going up from 400 meters drilled on the original horizontals in one direction. Now you're doing 6,000 meters in a 2-dimensional pattern. Your chances of hitting losses are going to increase if there are some features, and sure enough, that's what happened. So losses in the reservoir had always taken place, and on occasion appeared to be related to features. So you could draw a map, a plan view, and you could see, I'm drilling my second horizontal off this pad. I'm going to be hitting losses soon because I did on the well next to me and the well next to that. So there were these uncertain features that appeared to create these losses or cause these losses. Conventional fluid loss approaches had been used, but were becoming increasingly ineffective over time. As a petroleum engineer, the solution that was being applied was not one that I could really sign up for, and that was pumping cement in the reservoir. Effective sometimes in terms of curing the losses, but also curing production as well, quite nicely. Field on production at 100,000 barrels a day. What do? Extensive multilateral offtake. We've talked about this, and you see bit drop take place when you are drilling through these features on occasion. It's sufficient measurement to note that. So there's definitely something happening. And again, some pads appeared to be more susceptible than others, some kind of aerial relationship, which was also a feature. Frac gradient likely to be around here. There seemed to be this threshold pressure, ECD, at which we opened things up, and that was an interesting fact. And the mud weight itself and the ECD, mostly below that in the early wells, but I say coming to cross this with time. Cost of the losses in the pay zone. Wow. So cost of lost mud is relatively easy to calculate. It's a very finite. It's a consumable, and we can see over the 3 years that this is increasing. We're up into $3 million worth of lost mud. Rig NPT dramatically increasing year on year. Lost meterage drilling, which turns into lost meters of production. And so the percentage of the multilateral wells encountering it increasing as well, or the percentage of multilateral wells being drilled, I should say, increasing as well. So more multilateral wells, more losses, more cost. You're going up from 2 million to 12 million to 16 million. Where is this going to end? Is the fear. Number of multilaterals. So just the numbers in a tabular form here. Tailored LCM pills were being used, carbonate plugs as well, cement plugs, multiple cement plugs placed in the reservoir before eventually giving up on that location and moving on to the next one. And so lateral abandonment early in the drilling feature. Formation damage, of course, is going to be linked very much to all of this kill pill formulation, late well startup, the costs of just the additives that you're using, plugging of the ESPs when all of this comes back, and more workover, more pulling unit, more ESP, infant failure due to that, and the loss of reservoir meterage. Not easy to then go back and infill around multilats. That's one of the, when you commit to multilaterals, you've kind of committed to a one-time geometry. It's not that straightforward to go in and effectively add infill. And then just a split here on the kinds of losses: 5 meters cubed an hour, 12% of the time, all the way up to 30 meters cubed an hour, full on, 48% of the time. And here's the interesting thing: Eastern Siberia, of course, just like Canada, lots of snow in the winter, but just like Canada, free water is really difficult to get hold of. There is no one. It all drains into Lake Baikal. Lake Baikal holds 30% of all the fresh water on the planet. It's a mile deep and 700 kilometers long, and the entire eastern Siberian plain drains into Lake Baikal. There is no free water. There's no running water. So it's very difficult to, we helicopter water to rigs on occasion. That's what we have to do to move water in. So it's free water. So mud losses have this logistics issue associated with them as well, which is not the norm. And you have to cope with that. So many facets, if you like, to this issue. So trying conventional fluid, we all know how to what the treadmill of dealing with losses and the increasing cost and complexity that this contains. Conventional fluid loss additives, perhaps use of a stress cage approach, which I'll talk about a little later. Multiple cement plugs, but reducing impact of that approach. We looked at low energy drilling, dropping all of the pressure drops out of the system wherever we could, and gained ourselves a little bit of time by doing that. And then low head drilling with oil-based mud. We attempted that as well. We converted a rig over and did a couple of wells, but it wasn't as effective in terms of ECD as we'd hoped. And because we're drilling multilats, and you've got a lot of ECD when you're drilling these laterals, you've got a lot of small hole with the assembly in. And it's costly because the rules have changed in Russia, and so disposal of OBM, you kind of own those cuttings for the rest of history. The next 100 years, you don't just go dispose of them and pass them. You are liable, and it becomes very, very costly to manage cuttings, OBM cuttings. There'd been a lot of enthusiasm for low head drilling, like energized fluids. And I put this down to technical engineers. Our technical disciplines are very much like our children. We prefer our own, and we love working on things that are very interesting. And so all the engineers wanted to do MPD and energized fluid drum, but think 12 to 15 rigs with rotating heads, nitrogen generation, in the depths of winter, in the middle of nowhere, with poor logistics. Technically extremely interesting, but absolutely costly. Costly in terms of just the physical cost, but also the HSE cost, because it's not an oil field that's going to do high tech very easily. Again, it's much more like Canadian style oil field, which is more the agricultural end rather than the space race end of the field. So we also needed BHA communication, of course, because you're trying to directionally drill these multilaterals to a certain, you need that ability to communicate. And as you know, that becomes increasingly complicated in energized systems. And the solution that we actually implemented, which was quite novel, was low head drilling using entrailed hollow glass spheres in the standard mud systems for a direct reduction of SG. So though you may be familiar with hollow glass spheres, they're typically used in cementing systems when you have an ECD problem on cementing, and it's to get the ECD down so that you don't frack the cement away. And a lot of cement jobs have been fracked away over this industry's lifetime. But one of the ways to do this is to add these inert 50 micron spheres, which float in water, have a very low SG, and it allows you to just completely change your world in terms of ECD. So quite common in cement. Talking with some people earlier, I think in Vietnam there's a fractured basement field where they always pull tubing in this. They use this in the fluid when they want to pull tubing, because they want to keep a static fluid in the well, but if you try to kill the well, you kill the production that you're trying to get back, and so they use trained HGS for that. And there'd been one or two sidetracks around the world, infill in very mature fields where they'd just added to the mud. But this is the first true application that I'd come across, or we come across, where it's these spheres are being added into the mud system to give you a drilling system, full system, that you're then going to drill the well within the reservoir. So very low density, varying crush strengths, so you can buy them in varying grades so that they'll be more resistant to crush than others. So if you're in very deep wells or very long wells with a lot of attrition potential, they will crush as you drill. So you have to replace them. Of course, there are different ways of separating this material out as it comes to surface, which we'll talk about. But the point is they're inert. Apart from breathing, normal respiratory apparatus, you cut sacks and just add them to your mud system. They don't interact with anything. And a lot of fears when we talked about this, about how all the drilling equipment's going to plug, all of the production equipment's going to plug. And none of that occurred, but we'll talk a little bit about that as I go through it. So a very simplistic system, had been around for many years, had been used in cementing, was costly because there was only one manufacturer some 10 years ago. Now there are many, many manufacturers of this material, and the cost has appropriately become, it's much, much more affordable than it was. So we had a number of stages where a feasibility stage, the ability to mix and store and prepare on the rig, evaluation of consumption during some trials and benchmarking the costs against conventional strategies, and then developing a long-term strategy. And these are the phases that we passed through in 2018, 19, 20, or 19, 20, 21. Very compatible with the conventional baseline mud system. It's just an additive. But you do need to then consider the additives that you already have in your system for building filter cake and adjusting it to take into account not only the spheres in their normal state, but as you drill and you get crushed material within the system, it starts to replace the normal fluid loss additives that you put into a system. We've conservatively selected a high resistance crush system, 10K. So it was about in the middle of the range available, because we didn't want to do the pilot 2 or 3 wells and then say afterwards, if only we'd used 15K, or if only we'd used 10K. So we picked something that was a little conservative. That does affect the cost. In fact, since this, they've dropped down to 5K system, and it works quite well for them. So the true bulk density then optimized to achieve that, to get below that threshold pressure. And the particle size selected to we were looking to get a kind of a stress cage effect, which we saw, and I'll show some evidence of that as well. So if those of you familiar with stress gauge know that you can size particles in a mud system, the range of particles, the PSD, the particle size distribution, and you can drill across a formation, you can frack it with mud, and then you can plug the frack before it develops, certainly permeable formations. So in the Gulf of Mexico, this is standard practice stress caging that's been around for probably 20 years now, and you can drill with a mud weight that's 5,000 psi over the frac gradient relatively easily. But you have to keep that size distribution right, because you have to do, basically drillers doing really bad fracturing, doing really bad prop fracturing. Leak off takes place in front of the frac, and you plug, and then you can drill across a frac. You can drill with a mud weight way above a frac gradient. We believe that we might see some of this, and so we tried to size our range to capture that. And then an assessment made of how much did we need to do, 2 or 3 wells, and some extensive fluid loss testing for leak off control and drilling fluid parameters, which when the system was just added to the original mud, we got a hell of a filter cake pretty quickly. Not unsurprisingly, as a frac guy, I can tell you beads plug things really easily. They do it really, really well. They're really efficient. Because of all the other additives in the mud system, this is the typical mud cake. This is with hollow glass spheres. You obviously don't want this. And so changing the distribution in the mud system, so taking things out of the original mud system, not just adding in the hollow glass spheres, we were able to, on different disc sizes and slots, we're blocking 10 micron, 50 micron, 120 micron. So we're able to bridge these different sizes very easily. It's great bridging material. Again, as a frac guy and the screen out aficionado, what can I say? Beads plug really, really well. The mud characteristics, the standard biopolymer mud here, and then this hollow glass drilling fluid. So we're getting down to a mud weight of 0.95. That's where we wanted to be roughly with this mud for the ECD that we wanted to be at. And we're, again, relatively straightforward to achieve that. The mud, of course, is white, which kind of freaks people out a little bit, but other than that, it's just an inert mud system. And here are the changes that were made to the mud. All of this published material now. Looked at regain perm and followed the normal sequence, and actually looked at some acidization and some removal as well. I won't delve into this because it became a whole piece of work on its own. What I'll talk about is this: the standard mud system was giving about a 40% regained perm. The inadequate, just added to that standard mud system, hollow glass spheres, was giving us about 25, not where we needed to be. But then the redesigned mud, with the distribution that was required for plugging, was able to get us above where we were with the original mud, and I believe this work has continued to improve further as well. 3 trial wells were selected. A well we're just going to start drilling with hollow glass spheres mud, and so we drilled 2 of the planned laterals on a 7 lateral multilat, and then swapped to conventional mud. When we swapped to conventional mud, immediate losses took place. It's almost like you have to prove to the management, this is what it's doing. It's an ECD effect. Immediate losses on resumption of the drilling, which had to be treated in a conventional manner with cement plugs and everything else. And after 2 further laterals, they couldn't drill any further on that well. A horizontal, because we had a pad with older horizontals on, and we wanted to have a formation damage measure, and we drilled the entire lat with hollow glass spheres. All of the horizontals on this well had suffered from losses. This one didn't. Drill the entire reservoir section without any losses, and we'd never been able to do that, as I say, on this pad before. So an indicator that, again, it works to do that, and a production comparison then with the offsets. And then where we felt it was likely to be applied in the longer term, and this is where we were drilling a multilateral. We drilled 2 or 3 laterals. In this case, after just 3 laterals, we crossed something. One of the features started to show up, attempted to stem the losses. Usual treatments couldn't do it. Deployed HGS, losses stopped immediately. Continued to drill to LTD, adding a further 4 laterals and the motherboard tail. So very successful from that perspective. On-site mixing and handling of the hologlass spheres was issue-free, no problems or HSE risks. Of course, they are glass spheres. There will be glass powder in the sacks. There needs to be appropriate breathing protection in that when you're cutting sacks like that. Solids control performance was mixed. Centrifuges were probably the main issue, and operational execution of the 3-well pilot took place. No losses on these 3 wells where we've always previously had losses. Clear primary SG effect and a measured secondary stress cage effect. And what do I mean by that? By that I mean that we'd crossed the threshold pressure and see losses, change to HGS, drill ahead, no problem, go back to the normal mud system, and on the normal mud system, the threshold had moved higher. That means that something that's behind you has been stress caged, and that threshold to opening that up. So there were some features that were taking a certain amount of solids and a stress cage, an ability to place an inclusion within that and increase the threshold pressure for them to open up. Well reported in the papers on well A, where we drilled with HGS, able to keep the ECD where we wanted to until we couldn't anymore, and just the concentration of hologlass spheres within the well. Again, in this case, we drilled off. We allowed the ECD to increase, but because we were building a stress cage effect, we were allowing the deterioration of the hologlass spheres to take place. You lose about 10% for every kilometre that you drill of the effect. So if you don't add at that pace, you're deteriorating the effective ECD. But able to drill off and complete. And then just another example, losses while drilling, and then losses while attempting to place the standard mud system back in the hole and get our hologlass spheres back to surface so that we could use them again. So the survivability rate, the attrition rate, if you like, actually 20%. Our assumption had been 20% for a typical horizontal well. And it looked like it was about 10% for these 10,000 psi crushed spheres. I'm sure if they've dropped to 5,000, which will be much cheaper, then that attrition rate might be at 20%. Clean fluid looks like this. Dirty fluid after drilling, and you're beginning to see some crushed material. For the crushed material, again, there are lots of different ways of separating it. It sinks. It becomes great fluid loss additive. We had one of the advantages of multilaterals is that in this part of eastern Siberia, there's something called a TRAPS formation. It's a volcanic ash deposition. And you can spend a month trying to get across it because it's vuggy, cavernous losses. And you can spend a lot of money on fluid loss additives getting across it as well. This became our material to just dump in the wells when we encountered that. But when you drill multilats, you've got 8 trips across the overburden per pad instead of 15, which was helping from that perspective as well. On the 3 wells, just an indication of where we were losing material or where the material was being used. We had no issues at all with the directional drilling equipment and drilling with this material. And on production, when we move on with the pulling unit to run the ESP, some hologlass spheres will be found at surface in the first couple of 100 meters floating on top, which you could, if you would just circulate out, but no impact on the ESPs whatsoever. So just produced through them, or crushing, a lot like ceramic proppant. It's just not offensive enough to be a problem. The shale shakers worked as planned. Screen sizes were kept within range, and we had a mud settling tank, but you need to have a residence time, obviously, to get that to work. Desilter didn't work very well, and the desander with low performance, but tweaks were made to pipe work and operating envelopes, and this was addressed. Centrifuges were probably the biggest problem. We were getting rid of good mud along with cuttings and bad mud. And a lot of work was done in Nizhny Vartovsk with the mud company, back in Western Siberia at the main base, to see what could be done. A lot of subsequent work has been done by Exxon with the separation as well, because it's clear that they're lining up to do something with this kind of material in Guyana, I suspect, where they're probably dropping pore pressure very, very quickly. And so work can be done with a centrifuge to set it up such that it can give you the right form of separation. No impact on productivity whatsoever. We were very happy with the offset, and I've heard, since I haven't seen numbers, that the changes that they've constantly made to the mud system to improve the regain perm has improved the overall deliverability. Certainly not worse than prior. So hollow glass spheres significantly reduce the chance of losses occurring and the bridging of thief zones. Swap to a standard mud system reinitiates those losses, so just confirming it's all an ECD issue. A minimum concentration was determined to avoid the losses from actually taking place. No impact on downhole equipment, LWD or surface equipment. Low efficiency of the mud conditioning, but one thing that I'll talk about it in just a moment. If you have a central mud processing facility, then you have the residence time to deal with this more adequately, and that's where they were moving to. The attrition rate was quite reasonable, 0 problems mixing, production unaffected, and really great economics of the overall system. So we felt that we delivered on everything. We had expected to see a lubrication effect with beads as well. Something, we thought that we would see some friction reduction in the system. Didn't really detect that, which was a little bit of a shame, hoping to see a bit of a benefit from it, but nothing that was noticeable. And then, the centrifuge was addressed at a later date. The strategy that was then taken up was to classify losses on a pad basis, and the strategy for that pad would be selected as appropriate. So low losses you just deal with in the normal way. Moderate losses you may call out hollow glass spheres and use as started. So react if necessary based on the fluid loss response. And then a central plant with a centrifuge set up to recover that mud, process it and send it back to a location, reuse, reissue, again recovering the solids waste, the crushed spheres, so that they can be used as fluid loss additive. Continue to investigate formation damage as they did, and then trialing a lower crush strength just to knock cost. The one great thing Russians are good at is knocking cost out of everything. You implement something, it technically works, then it's stand back and watch them make it cheap as chips. Short term, sometime all performed now. Midterm skip tender has been performed. Central plant is being scoped, and in 2023, the last I heard, it's now being used across multiple fields in Western Siberia as well as Eastern Siberia. So on an economic basis, if you're drilling a lot in the reservoir, then and we tend to be more and more now, then it can be a very cost-effective means of delivering it. I'd like to thank the co-authors of a number of these papers, Vitaly Shereshorin and Yevgeny Tusov, who contributed. And most recently, there was this APOG-C paper. This is our birch leaf, very proud of it, 20,000 meters and 12,000 meters in the reservoir, and hollow glass spheres, what they look like. But a great solution at the right place in the right time to help us resolve the problem and keep the 100,000 barrel a day plant full, even though perhaps that might not have been the long-term best plan. Certainly from an MPV perspective, it was best, but we could argue about that forever. Yeah. Thank you.
Thank you, Martin. I think that might wasn't working as well. This okay. Thank you, Martin. I see a lot of drillers in the room, so I'm sure there's a lot of questions today. So again, please raise your hand, let us know who you are, and then ask the questions. First one. Actually, I think that might
Oh, you have to stand more. Okay. Um, if no one in the room, let me start and lead from beginning. I think
yeah. Yeah. Okay. Sorry for technical problem. Okay, Professor, yours. Question, please. You continue. You want to continue? No. Go on.
I'm sorry for that. Um, you did mention in one of your slides that you say ESP production is unaffected.
Yes.
I'm not sure, is that because of the special treatment when you do the extra wellbore cleanup, or is it kind of more affected by nature of it?
So, so there were two points. The ESPs were not affected by the solids. So the fact that the laterals contain these spheres at the end of drilling, 50 micron, they were unaffected. The ESP and production functionality was unaffected by them. It was, it was just produced through without it registering any problem or plugging or causing erosion or issues on the pumps themselves. And then from a formation damage perspective, the PI of the wells is actually better now than it was previously. So there's no damage to the formation itself. So the production side got better rather than worse. It's when you use ceramic solids like this, it's a lot like fracturing. The fractures always produce. They always produce. If you go to Alaska and you go to Alyeska, they empty one of the storage tanks every year. At Valdez, I should say, and there's 2 feet of ceramic proppant in the bottom of the tank of each tank that they do every year. It's come all the way through the processing facility, all the way down the Alyeska pipeline, all the way to Valdez. It's such an inert material, ceramic. It doesn't erode. It passes through equipment rather than eroding it, unlike sand. So it's. I was not surprised at all when there was really nothing reported. Silence is good. Silence means they don't want to talk to. There's nothing I need to resolve. No issues.
Okay, thank you. Any questions? Come on, drillers. I never seen drillers chime. It's maybe, oh, you're not a driller. Would you ask?
I have a driller behind me. Oh, actually, many. So we give the microphone to him. Philip Husky from MEDCO Energy. First of all, I suspect many of us in this room are going 7 multilaterals, $2.7 million, and our heads are falling off. I'll let you address that in a minute.
Yeah.
But love the productivity index, concept. One question and one ask. Question: have you seen anything this applied to carbonate reservoirs with a significant fracturing to support losses or anything? And the ask is, I like the innovation. How can we get your brain on our limited tire resources to help us out on the drilling and mud control?
Yeah, okay. So let me take those on. So carbonate reservoirs, I'm pretty certain, yes, there are. Part of the process that we followed when we looked at this was to scour One Petro and all the libraries and find out what had been published and who had done what. So one thing I'm always very always do very keen to do is ensure everything's referenced. So the papers that are on this slide, if you get hold of those papers, there are 20 and 30 references on where hollow-glass spheres have been used. Again, mostly in cementing, but I'm pretty sure that there have been some sidetracking in the Middle East as well in carbonates. That had suffered from that. So that's point one. Cost. I think there's a buried cost here. It is tremendously cheap to drill in Russia, but that's often because if you go to Western Siberia, you go to Nizhny Vartovsk, and it's owned. The town is owned by was TNK-BP, but it's now owned by Rosneft. The reason it's there and everything that's taken there is owned by the company, and so there's probably an underlying cost that's not accounted for, but it is tremendously cheap to drill. Even if you were to double those costs, you'd still be quite comfortable, I would think. But there's an underlying piece, I suspect, that's not accounted for. A lot of those drilling rigs were Rosneft drilling as well. Great rigs, but owned by the company. So again, are all the true costs being passed through, or is there some under the table work going on? And then your third point was about how to.
I'm not sure you know about our wonderful reservoirs here. We have a few carbonates and a lot of lacustrine and interbedded, river systems. So I'm just wondering if you had a chance to think about our reservoirs and how we could apply this technology.
Yeah, let me turn it around and put it in a different. I love technology and I love technical. People think of me as a frac engineer, but I'm a kind of a well enhancement engineer. I like to solve problems. So if there's a problem that needs resolving, if major losses, drilling lots of hole in the reservoir, or PI on wells is a major issue, then yeah, I think it's. I tend not to come up with technical solutions and then try and find and create problems for them. It's the other way. And so, what are the driving factors here? Because they do differ around the world. I'm thoroughly impressed when I go to for multilats, when I go to Canada and see what they've done in Canada. It's just not published. The amount of meterage that they drill in a single hole within the reservoir in tight oil is just phenomenal, and there's so little published about it. I find astonishing. I'd be screaming from the rooftops that I was putting 30,000 meters in a tight oil reservoir cost effectively if I was doing it, but I guess they're just too busy doing it to talk about it. So there are great solutions out there, but I think on a case by case basis, you break down what is the underlying factors that make my reservoirs challenging? Is it PI? Is it water breakthrough? Is it what's the pressure support? What's the mix? And then what are the technologies that suit taking that on? But this will just become for me just another weapon in my arsenal that I will keep at the back of my head. And when I spot something, go and read that paper or go and have a look at that.
Like the kids crying or something, you throw some holy glass.
There you go. Yeah. Thank you.
Any more questions? Students, you want to ask something? You've been prepared.
So, hi, Mr. My name is Warrington Bourne Kipakon, and I'm here from Chulalongkorn University, Faculty of Science, Geology. So, I think you mentioned the HSG liquid after you do it. So, when you create 10% was tried, so how about the 90% left? Are you reuse this or you have another way to prepare with it?
Yeah, so a large part of the economics are ensuring that the circulation system retains the appropriate level of hollow glass spheres, and so you set up your separation system to recover that waste 10%, and add sufficient volumes to continue drilling. Although, as indicated, the stress cage effect, which I don't know how far they've progressed with that, allows you to drill off and change that threshold pressure. Stress cages, I find stress cage an entirely fascinating subject as a frac engineer. As a frac engineer, I've been arguing about what frac width is for 40 years, and then the mudmen in drilling decided what the width was and came up with a particle distribution to plug it in a couple of years, it seems. So that's the stress cage approach allows you to change that threshold, which allows you to reduce the concentration of HGS. So there's a lot of optimization to do on a case-by-case basis, and it's all related to cost. As I say, the original spheres were quite expensive because there was only one manufacturer. Now there are multiple manufacturers, and it's an extremely affordable additive. So yeah, not fluid loss additive was what we did with the waste material. It got put to good use, and I'm sure that there'll be other applications of the hollow glass spheres in the drilling environment as well. Now we're comfortable with it in a mud. Thank you for the question.
Thank you.
Okay. We have time for last question. Okay.
Hi, thank you for your talk. My name is Krawan from PTTEP. I'm not a driller. I'm a geologist. Um, it's quite new, kind of subject for me, but I'm just thinking about the condition in Thailand where we have high temperature, high pressure. Would the hollow sphere glass be suitable for this environment, or would there be a future generation, if it doesn't work or if it's not suitable, would there be, future innovation that would lead to something similar that could work in our environment or reservoir?
It's a good question. The spheres themselves, there is no temperature limitation really on the spheres. From a pressure perspective, you pitch the crush resistance that you choose would be directly related to the environment that you're working in. So you can get them up to 19,000 psi crush resistance, which is extremely stubborn, environment. I wouldn't think that you would need that even in HPHT here. So the material, it's a boring material. It's been around decades. It really has. It's just that this is a different use for it, which the industry has touched upon, but never really taken on it. I guess, and that's why I raised the point about Exxon. It's interesting to see Exxon doing research in this area, and then publishing on it, because they never publish. So seeing them doing this research, fundamental research, and publishing on it says that to me that they've got an asset somewhere that they're going to put this to work on pretty quick, and they were calling around looking for feedback. So I expect we're going to see more published on the use of hollow glass spheres for drilling entire reservoir sections in the future. Thank you for the question.
Okay, so I think Martin will still have a few times, after the meeting. So if you have more questions, you can just ask him later. So on behalf of SPE Thailand, may I have Kun Pinut, the awards program chair, to present the token of appreciation for the speaker this evening. So you know where. Okay, 1, 2, 3.
So right now it's time for the lucky draw for the one who forget to write in it. Please send to our hotel staff for the last chance. Okay. Moving to the next meeting, we have Brian told me our SPE distinguished lecturer in the topic of liability is forever. Uh, so you may wonder, like, what is SPE distinguished lecturer? This is the most successful program that we initiated since 1961. So right now, the program is open for everyone to register. We will close in 15 March 2025. So basically, we have the nominee criteria that you ideally 10-year plus experience that you want to share the knowledge to our community and subject to the global interest. You don't need to be like this the PhD for like 30 or 40 years experience. You can register in our website here. And final selection for the Bangkok is September this year. We will announce the result. So if you want to be our SPE Distinguished Lecturer, please register via this link. For the upcoming event, you can check on our website. We have SPWLA for Kun Numan Petrophysics, Interpretation, Evaluation, and Service for SPWLA, 27 February this month. Our neighbor, we have SEC 2025, 6 to 9 May. And right now, CPEC is open for the free membership for geologist student. I see some geologist student here. You can register for free for CPEC membership. And right now, we have a lot of channel that you can communicate with us. We have Facebook page, LinkedIn, and Line official. You can also register for the monthly event like this via our Line official as well. And this is the time for the lucky draw ค่ะ welcome คุณ Martin for the first prize.
The price is the what is it? Wireless earphone.
Okay, so the next round of FA Cup, Coventry will play. No, hang on. No, it's Sompong C work strings. Not for you. Not for me. Thank you very much. Thank you. Thank you. Yes, Sukutai Chinduchitan, I think, in CPR. I hope I pronounced that.
Thank you. Thank you.
Thank you very much.
So if you have time, like Kun Kasian said, you can discuss with Martin after the event. But if someone wants some drink, we have newly opened bar at the first floor of this hotel. It's just renovated and it's called Kukuba. Right now it's having promotion, buy one get one free. If you want, can join us downstairs. And this is all of our event today. Thank you all for coming tonight. Thank you.
Thank you very much. Please distribute the slide and share.
ปิดโปรแกรมได้เลยใช่ไหมแต่ละไมค์คือเสียงปิดโปรแกรมได้เลยเนาะ